Hello there. Today we're going to be talking about how to solve quadratic equations by graphing. So, a good thing to remember when we have quadratic equations is that we're going to end up with a parabola. Parabolas can cross the x-axis 1, 2, or 0 times, so that would pertain to the number of solutions we could possibly have for a parabola. It is possible for us to have 2 solutions, 1 solution, or 0 solutions, depending on the situation. So the reason we're starting off by graphing is to visually show you what these solutions to a parabola would end up looking like. So let's look at this equation here, x squared plus 2x equals 3. Our strategy to do this is going to be by solving it. So the way we're going to start is we're going to subtract 3 from both sides. The reason we're doing this is because we want our equation to have one side be a parabola in standard form, and we want the other side to be equal 0. When solving quadratics, it's very, very, very important to have one side equal 0. If you wanted to represent this 0 on the graph, it would look like this line going across which is the x-axis. So visually, that's what this is saying, is that this parabola, x squared plus 2x minus 3, is equal to 0, which is somewhere along this line. Okay, so now we just need to figure out how to graph x squared plus 2x minus 3 is equal to 0. Well, we don't know if it's going to work out nicely into intercept form, so why don't we use our new method of looking for the vertex that we learned on Friday. So the vertex is going to be negative b divided by 2a, and then f of negative b over 2a. Now this is, so we don't see f of x here, but basically it's going to be the y value when we plug in negative b over 2a. So this will be, b is 2, so it'll be negative 2 divided by 2a is 1 times 1, and then f of negative 1, because this simplifies to negative 1, which is going to become negative 1, and then if I plug in negative 1 here, I'm going to get negative 1 squared plus 2 times negative 1 minus 3, which will become negative 1. 1 minus 2 is 1 minus 2 is negative 1, and then minus 3 is negative 4. So we have our vertex at the point negative 1, negative 4, which is down here. Now if we look at this, since a equals 1, this means that there is no stretch or shrink. So that means when I go over 1 from the vertex, I've gone up 1, because that's our general movement, and then when I've gone over 2, I've gone up 4. So it looks like I can graph this parabola like so. Now let's look at this parabola. So if this parabola represents x squared plus 2x minus 3, and we want to find when it equals 0, then the intersect between this red line, which represents x equals 0, y equals 0, and the blue parabola will have solutions at the roots of the parabola, which is at the points 1, 0, and the other point is negative 3, 0. So this tells me that our solution is x equals 1 and x equals negative 3. Another way you could have done it is to just have factored this and turned it into our intercept form, but I want to practice using the method for graphing parabolas without converting it right now. So these are our 2 solutions. And note that I didn't write points here. The reason I didn't write points is because this is asking me, when I'm asking to solve x squared plus 2x equals 3, I'm being asked to find x values. I'm not being asked to find the roots of a parabola. Let's take a look at solving x squared minus 8x equals negative 16 by graphing. First thing we're going to do is make this equation equal 0, and to do that we're going to add 16 on both sides. Now we have x squared minus 8x plus 16 is equal to, and I'm going to write the 0 in red, because once again, this represents the horizontal line of y equals 0, which we're trying to find the intersect of graphically. Now we need to graph this parabola, so I'm going to find the vertex. And also I notice that a equals 1. This value here is 1. Remember that standard form is ax squared plus bx plus c, where a is the vertical stretch or shrink. So there's no stretch or shrink. So our vertex is going to be negative b over 2a, and then f of negative b over 2a. So if I plug that in, I'm going to get b is negative 8, so it's going to be negative 8 divided by 2 times a, which is 1, and then f of, this is going to be 4, negative, this is going to be positive 8 divided by 2, which is 4, which will become 4 f of 4, okay, f of 4 is equal to 4 squared minus 8 times 4 plus 16, which is equal to 16, minus 64. The reason I knew this was 64 is because, oh, not 64, sorry. This is 32 plus 16. So this was going to be equaling 0 because 16 plus 16 is 32, and then I take 32 away. So our vertex is 4, 0, which is at the point, which is right here on our parabola. Now we want to graph this, and since we know there's no stretch or shrink, when I go over 1, I go up 1, and then when I go over 2, I've gone up 4. So if I were to draw my parabola, it would look like this. But I don't actually need to draw it any further than this because I can see exactly where it hits the x-axis, which is at the point 4, 0, which means that x equals 4 is our solution. Here we have one solution. Last time we had 2 solutions. Now let's solve negative x squared is equal to 2x squared plus 4 by graphing. Here, what I'm going to do is I'm going to add x squared to both sides because that is the most efficient way to make one side equal 0. But I could have also subtracted everything for this side and brought it over to the left. Those both would have been valid, but I'm just going to choose to do it this way. So I'm going to get 0 is equal to x squared plus 2x plus 4. So once again, 0, why don't I write that in red, is going to be this horizontal line, and then x squared plus 2x plus 4 is a parabola we want to find the vertex of. So we know that a equals 1, which means there's no stretch or shrink. Imagine I also crossed out shrink. So we're going to find the vertex, which is at the point negative b divided by 2a, and then f of that value, because we want to find the y value of the function. So b is 2 here, so this is going to be negative 2 divided by 2, and then f of negative 2 divided by 2, which will become f of negative 1. Whoops, sorry. It's going to become negative 1 and then f of negative 1. Okay, when I plug in f of negative 1, I get negative 1 squared plus 2 times negative 1 plus 4, which equals 1 minus 2 plus 4, which is going to equal 3. So our vertex is negative 1, 3, which is right here. Then since I don't have a vertical stretch or shrink and it's not flipped, when I go over 1, I go up 1. So my parabola is going to look something like this. Here, however, it has not crossed the x-axis, which is what we're trying to find, because we're trying to find the intersection of this parabola with this horizontal line that is the x-axis. So this means there are no solutions. That is our answer, is just to say no solutions. if you're curious why there were no solutions, what we can do is we can graph this parabola and this line separately. So let's graph negative x squared, and we'll do this one in white, and we'll do this other one, this 2x plus 4 in red. So negative x squared is basically the normal parabola of x squared, except this just has one flip in it. So we're just going to look something like this. When we go over 1, we go up 1, and then when we go over 2, we go down 4. So our parabola is going to look something like this. If we just draw a rough sketch of it. Oops. Okay, and now let's try graphing 2x plus 4. Well, this is a line with slope 2 and the y-intercept of 4, which is up here. So when we go over 1, it goes up 2 because of its slope. So it looks like it's going to cross there. And it's going to go... and it's going to look like it goes something like this. So if we're trying to say negative x squared equals 2x plus 4, this is also saying what is the intersection of negative x squared with the line 2x plus 4, and it looks like these graphs never cross, which means that there are no solutions.